Welcome to AV3-2, area of a circle. By the end of this lesson, you'll be able to calculate the area of a circle. The formula for area of a circle is pi times radius squared. So A stands for area, R stands for radius. There are three GeoGebra visual proofs of why the area of a circle, why the formula works the way it does. You can find these in Schoology, so you can pause now and go play with them and understand, or after the video, that's a good time as well. Okay, let's take a look at some examples. So here we have a radius of 4 inches and we need to find the area. We need to find that exact area. So we're going to use area equals pi r squared. We know our radius is 4, so 4 squared. 4 squared is 16. We leave it in terms of pi. We don't touch that pi button unless it asks for an approximation, but here it's asking for the exact. In addition, it is very important that number goes in front of pi. So our answer is 16 pi inches squared. In our second example, we have area equals 36 pi and we're trying to find our radius. So again, area equals pi r squared. I'm going to substitute 36 pi for the area equals pi r squared. Now we're trying to get r all by itself, so we're going to divide both sides by pi. This will simplify. Pi divided by pi reduces, so I just have 36 equals r squared. R is still not alone, so we need to undo squaring, which is by taking the square root of both sides. R equals 6, so 6 inches. Okay, so let's take a look at this one. Our third example, circumference equals 18 pi, and we're trying to find our area. In our area formula, there is no circumference. So we need to go back to what we learned yesterday, that circumference equals 2 pi r, and we're going to solve for radius, or r, first. So I'm going to substitute 18 pi for c equals 2 pi r. I'm going to divide both sides by 2 pi. Our pi's cancel. 18 divided by 2 is 9. So the radius is 9. Now I can substitute that into our formula. Area equals pi r squared. Area equals pi times radius of 9 squared. 9 times 9 is 81. So we have 81 pi. The area is 81 pi inches. Again, we need to leave it in terms of pi. All right, in this example, it's asking to find the area of the blue. Looks a little blue-green to me, but that's the area we need to find. So what we're going to do is we're going to find the area of the whole circle, and we are going to subtract away the area of the orange rectangle, and that will give us the area of the blue. All right, let's start with the area of the circle. If I look here, I know that this point is at the origin, or 0, 0. I know that this line would be considered my radius, and I know that since this point has a y value of 13, that means my radius is 13. So for area of a circle, we have pi r squared as our formula. So we're going to do pi times 13 squared. My area of the orange is a rectangle, so base times height is our formula. On our rectangle, we have this point, and it's at 5, negative 12. That tells me that this length here is 5. Which means that this length over here must also be 5. I also know that this length here is going to be 12, based on our point, because it's down negative 12. I also know, since we can assume this is a symmetrical rectangle, the top here goes up to 12 as well, so that length is going to be 12. Now I know 12 plus 12 is 24. 5 plus 5 is 10. So we are going to do minus, over here our base is 10 and the height of the rectangle is 24. So now we can keep solving. 13 squared is 169. Pi minus 10 times 24 is 240. At this point, some of you may want to plug it in your calculator, but we are asked for an exact answer, so we cannot go any further. This is going to be our final answer, 169 pi minus 240. Now you might be looking at this and thinking, but 169 is smaller or is less than 240, so it's going to give me a negative area. That is not the case because we'd have to take 169 and multiply it by pi first. And remember, pi is 3.1415 and so on. So it's actually going to be a much larger number. So your final answer here, again, is 169 pi minus 240. Leave it like that. You could always check in a calculator just to make sure if that makes you feel better, but this is the final answer. Okay, we have another example here. We're trying to find the area of the orange this time. So what we're going to do is we're going to find the area of the circle, and we're going to subtract away the area of that triangle, and that will give us the area of the orange. So let's recall area of a circle. We have pi r squared. If I look at my circle, I can see here's the center at 0, 0. And I can find and use this radius, this point it tells me is at 5, 0. So the radius is 5. So pi times 5 squared. Now if we move over to the triangle, we know that the area of a triangle is minus 1/2 base times height. We can see here that this point is at 4, -3, which means this distance is 4. On the other side, I can see that this distance here is also 4 because my point is at -4, -3. This helps us find the base of the triangle. 4 plus 4 is 8. Now I need to find the height. I can tell that this length here is 3 based on our points that are given. Then from here all the way up to the top of the triangle, I can see that the top of the triangle is on my circle, which means that that length I just drew is the radius, and we already find that the radius is 5. So the total height here is 8. I'm going to substitute what I know, minus 1/2. The base of the triangle we found was 8. The height of the triangle was also 8. Now we're going to just simplify. So 5 squared is 25, pi minus 8 times 8 is 64, divided by 2 is 32. And again, just like last time, I'm not plugging this into my calculator. I am leaving this as my final answer. We want to leave it in terms of pi. 25 pi minus 32 is the exact answer. Here's another little joke for you to end our lesson. If you don't get it, it's okay. If you do, it's kind of funny. Go ahead and start working on the practice.